This is the second video that we're going to be dealing with trigonometric functions, and this is for both grade 11 and grade 12. So, to begin, we're given a question here where it says, sketched below are the graphs of the function f of x is equal to cos x plus q, and g of x, which is equal to 2 sine bx, for x is an element between negative 60 and 120 degrees. So, to begin with, whenever you get into an exam and you get onto the question that involves trig functions, especially in a question like this, where you're going to need to figure out the parameters on your own. So you're going to be needing to figure out the parameters. And basically what this means is that the equation is not given to you. And when that's the case, you've got to look at what you're given. And we'll start off with f of x over here. We know that in a standard form of a cos function, it should be f of x is a cos k x minus p plus q. You should know exactly what the a value means, the k, the p, and the q. And you can see that what we're given in the question is simply cos x plus q. So we don't have to worry about a k value or a p value. All we worry about is q, and you know that that is a vertical shift. It's a vertical shift. So we know that we're dealing with a cos function that has been shifted vertically. Likewise, if we go and then have a look at g of x, which is for sine, we know that g of x should have the formula a sine k x minus p plus q. But again, we don't have to worry about the p or the q. All we know is that for the 2 in front, we've basically gone and increased the amplitude. That's what the a stood for. And we've also got a b value in front there, which means that there is a period change. And so those are a few important facts that you can take out from the question immediately. The last bit that I've highlighted in green over here, where it speaks about x being an element between negative 60 and 180, that is basically the domain that we are given. So it's all the x values. So it's telling us that we've drawn these two functions, f of x and g of x, out, but we've only drawn them from negative 60 to 120. So we don't worry about anything that's happening after those 2 points over there. We're only interested in the domain between those 2 points. So, to start with, it says, write down the coordinates of the maximum turning point of g of x in the given interval. So this function over here that I've highlighted in blue, that is g of x, and they want the maximum turning point. Now, whenever you see maximum turning point, they're asking for the highest point on the positive part of the y-axis. And I hope you can see that if we're strictly focusing on the y-axis, the highest point is over there at the 2, and the x-coordinate is 30 degrees. So if you wanted the coordinates of that turning point, or the maximum point, you could say it as the maximum would have an x-coordinate of 30 degrees and a y-coordinate of 2. Remember, we only measure along the x-axis in degrees, not the y-axis as well. The second question that we've got over here it says determine for which values of x, so we're only interested in x values. And whenever you see something like this where it says determine the values of x, you know that they want an answer in the form of a domain. So you're either going to write it using interval notation, where you'd have something like x is an element with the round and the open brackets, or they want you to write the answer where we've got x is greater than, or x is less than, or maybe x is even between values. So you will have definitely an answer that fits into our interval notation, or using some form of inequality notation. And it's up to you which one you're more comfortable using. But the question then goes on to say, for where f of x, so in other words, the cos function, is strictly increasing in the given interval. So whenever you see something about increasing or decreasing, they are talking about the gradient of the function. Now, if you think of a straight line function, let's say we draw two straight line functions. We can either have a function going up or going down. When it's going up, that refers to an increase. When it's going down, that refers to a decrease. So you almost want to imagine, if I was walking up along this line, would I be going up for an increase or going down for a decrease? So by applying that principle then to our function f, you've got to ask yourself, in which position along f would I be walking upwards? And you can clearly see that if I started over here, I would be walking up along, but the moment I got to this turning point over there, for the rest of the way, you would be walking downwards. And that's the best way to look at it. Wherever you see a turning point or a maximum, so I'll write here, maximum or minimum is often where, or all the time actually, is where the gradient will change. So if you're increasing and you hit a turning point, then you will be decreasing. If you are decreasing and you hit a turning point, then you would be increasing. And so from this, the question asks, when is it increasing? Well, he's only increasing from there to there. And afterwards, he begins decreasing. So we need to know, what are the values of x from there to there? Well, you can see it's from negative 60 to 0. So your final answer in this question will be x is an element, and we can say from negative 60 degrees to 0. The 0 will have a round bracket, and I'll explain why in a second. If you wrote that in inequality notation, the answer would be x is between negative 60 and 0. Again, it's not inclusive in both cases. And the reason for that is actually quite interesting. If we walk along any sort of curve, whether it be a trig function or even a parabola or hyperbola, anything like that that has a turning point on it, the point that is a turning point will always have a gradient of 0. And the reason for that is quite interesting. Going back to the idea of using a straight line, if I picked any point along here between negative 60 and 0, and I drew a straight line like so, it would always be increasing if it touched just that point. So in other words, drawing a tangent. Whereas if I drew a tangent to touch at the turning point, it would be flat. It would be perfectly horizontal. And the gradient of any horizontal line, you'll remember back from grade 10, is 0. So the gradient at a turning point is 0. So if you wanted to extend that and look at the function g of x in green, you'll see that we've got a turning point there, there, and there. And in that place, the gradient will be 0. Over there, the gradient will be 0. And over there, the gradient will be 0. At any turning point, it's 0. And so, can we say that x is increasing at 0? No, we can't, because the gradient is 0 there, and therefore, we write that non-inclusive sign. Let's then go ahead and have a look at question 3. So for question 3 here, it says, determine the value of b and q. So we already said earlier that q, that referred to a vertical shift. And we also said that whenever we're trying to find these values, if you watch the video on theory, we would need to compare what we're given, and we would compare it with the basic function. So in this case, the basic function would be y is equal to cos of x. And if you were to sketch out cos of x, by now you should see it looks something like this, where we start at 0 and 1. Then over there we have 90. There's our 180, our 270, and we end again with a maximum at 360. And if we went to then sketch that onto our graph over here, we see that we would start at 1, we'd have that 0 at 90, and something like that. And that makes sense, because you can see how the distance between there and there shows that we have moved vertically. Now, for some of us, we might be able to sort of look at this and say, okay, we're looking at an answer over there that's probably going to be roughly about a half. But we can't just say that. We need to figure out a way to work it out mathematically. And often when that happens, you're going to either look at your y-intercepts or your x-intercept and use that as a calculation. Remember, for a y-intercept, that is where you let x equal 0. For an x-intercept, that is where you let y equal 0. Now, we can't use a y-intercept in this case, because that's the point that we're looking for over there. We can, however, use this x-intercept over there, where we've got the coordinates of 60 and 0. And what we're going to go do is plug that straight into our formula for f of x. So by doing that, we're going to get that f of x equals cos x plus q, and we're going to sub a point in, which is 60 degrees and 0, and there we're going to get 0 is equal to cos of 60 plus q. And you guys will know that cos of 60 is actually a special angle. So we would get 0 is equal to a half plus q. Move the half over, and we will get that q is negative a half. And so the formula over here is f of x is equal to cos x minus a half. And that's pretty much what we saw would happen. So we've shifted f of x from a normal cos function down by half a unit. Now we can go on and have a look at that value of b. When dealing with the value of b, we mentioned earlier that that referred to a period shift. Now the period is basically the number of degrees along the x-axis that it takes to make one wavelength. So we can see that from there, to make one wavelength, and for a sine graph, it's got to have one peak or one maximum and one minimum. So there we have our one maximum and our one minimum. So we can work out then that the period of this graph that we are given, g of x, is 120 degrees, because that is the value over there, 120 degrees. And then we had a formula that we could use to work out that value of b or value of k in a given question. And the formula was given to us, in this case we'll use b instead of k, is equal to the normal period of a sine function, and you should know that the normal period of a sine and a cos function is 360 degrees, and the normal period of a tan function is 180 degrees. And so we would write it as 360 degrees over the period of the function. And in this case, we are told that the period is 120 degrees. And so, to get that value of b, we would say b is equal to 360 over 120, which is 3. And that would be our value of b. This formula over here is very important for dealing with the periods, and that's why it's so important that you know what the period of those normal functions have. So just to make sure everyone understands, a normal sine function like that, from there to there is 360 degrees, whereas in this question, to get one full cycle is only 120 degrees. And so you know then that this formula is sine 3x. Now this fourth question is very important. So it starts off by saying, determine the values of x. And again, whenever you see a question that says determine the values of x or determine the values of y, you know that they want you to express it either in inequality notation or in interval notation. So it's sort of like a whole bunch of values that they want you to have a look at and say, what is the function behaving like between these points or after these points or something like that. And often what you will get is something that looks like this, where they've said f of x times g of x is less than 0. Now, another way that they often represent this could be maybe f of x divided by g of x is less than 0. And whenever you see something like this, basically what they're saying to you is look at the function and ask yourself what will happen when you multiply any two values of the function together as you move across the function. And so basically, when we try and answer things like this, you will either get it being less than 0, so less than 0, or greater than 0. And all you have to ask yourself is for something to be less than 0, you know that you need one positive and one negative. Because if something is less than 0, it's negative. And how do you get a negative number? By multiplying a positive and a negative. Likewise, if something is greater than 0, it must be positive. And the way to get a positive is either to have two positives or to have two negatives. Now, how we work with that in functions is by saying, well, to have one negative and one positive, you need to have one above the x-axis and one below. Likewise, then, for two positives or two negatives, they must either both be above or both below. And so when we're looking at this, we are told quite clearly there that that is less than 0. So when you see less than 0, it's saying, when will f of x divided by g of x, or f of x times g of x, when will that be negative? And in order to get a negative, we know that one will have to be above the x-axis and the other one will have to be below the x-axis. So start looking at your function, and we start at negative 60. And do you see that from negative 60, all the way to 0, f of x is above the x-axis. And at the same time, if we highlighted g of x, you'll see that for that entire interval there, g of x is below the x-axis. So 1 is above, 1 is below. So the first bit of the answer that you can give is x is an element from -60 to 0. And it might be important to realize that at -60 and 0, they would actually not come out as negative, and it's not inclusive over there, so it doesn't include 0. So we would in fact have round brackets. If you'd used your inequality notation, it would be x is from -60 to 0. Because from -60 to 0, we see that at every point there, one of the functions is above and one of the functions is below. And then if we carry on highlighting, we'll see that over here, f of x is above the x-axis and g of x is above the x-axis. So for this entire point from there to there, they are both above the x-axis. And likewise, if we carry on, there goes f of x below the x-axis, and there goes g of x below the x-axis. And so I often say, look for the points where the graphs cut the x-axis and just compare what happens afterwards. And in both cases, after the 0 over here, they are both either above or they are both below. And we are not interested in both being above or both being below. We need one to be above and one to be below. And so the only answer here is what we've already written down. We're now going to look at the second question. So this is question 2 that we'll be dealing with. And it says here that in the diagram below, the graph of f of x, which is equal to -3 sine x over 2, and g of x, which is 2 cos x minus 60, are drawn in the interval where x is between -180 and 180. Then it says that t, pq, which is that point over there, is a turning point of g with p less than 0. So, let us then begin looking at the questions. So the first question that it asks us is to write down the period of f of x. Now, whenever you see a question that involves period, you know that the formula that we're given is that k is equal to 360 degrees when we've got sine or cos, divided by the period of the function. Now, what we're given in this case for f of x is -3 sine, and then we've got x over 2. Now, we can actually write that instead as a half x. So x over 2 and a half x is the exact same thing, but it just makes it a little bit more clear for us to see that half in front of it. And so when we see that half in front of it, we can then go ahead and fill that straight away in to our value of k. Because we know that the normal standard form would be y is equal to a sine and then k x. And so that k is whatever comes in front of the x. So when we substitute that in, we will get a half is equal to 360 over the period. So we want to go ahead and make the period the subject of the formula. So period would equal 360 degrees divided by a half. And if you plug that in your calculator, you would get 720 degrees. So the period of the function f of x is 720 degrees. The second question then says, write down the range of g of x. And just so you all remember, we've got two words. We've got domain and we've got range. Domain speaks about all the x values in an equation, and range speaks about all the y values in a function. So we want to know, for the function g of x, what are all the possible y values? Now, whenever we're dealing with a trig function, if we sort of sketch it out over here, and it doesn't matter for the moment which one we're talking about, but basically, whenever you're asked about range, they're asking about the difference between the maximum and the minimum. So what is this maximum coordinate and what is the minimum coordinate? And the range will be between that max and that min. And so you'll remember I wrote out a formula that to find the max or the min, what you've got to go and do is go plus or minus a plus q. That was the formula, where q refers to the vertical shift and a is the amplitude. Now for g of x over here, you can see that we don't have a q value on the end. So we don't even have to worry about that over here. And so we know that our maximum will be plus or minus 2, because that 2 there is our a value. And so you can take away then that your max is equal to positive 2 and your min is equal to negative 2. And so your range, you would write it out as y is an element including from negative 2 to positive 2. Alternatively, you can use inequality notation, and we can say y is between negative 2 and 2. Again, it's referring to our maximum value and our minimum value. And this formula will be much more important because often we will have a q value attached to the end as well. The next bit over here, it says write down the value of f of p minus g of p. And again, that p value is referring to that coordinate of t. So it's basically saying here that p is the x value at point t. And it goes on then to tell us that p is less than 0, which means it's on the negative part of the x-axis. Now, it should be quite easy for us to actually tell because we already know that t is a turning point, and at the turning points, that is a synonym for when we have a maximum or a minimum. So anytime you see the words turning point or maximum and minimum, we're referring to the same thing in a sense. And so the minimum, which we calculated in the previous question, if we went across over there, would actually be negative 2. So we therefore know that the y-coordinate of t is negative 2. And if we wanted to go and collect the x-coordinate, we would simply need to substitute 2 into our equation for g of x. So let's start off by doing that then. We've got that g of x is equal to 2 cos x minus 60, and we're going to substitute in our y-coordinate, which is negative 2. So it's going to be negative 2 is equal to 2 cos x minus 60. And then we're going to divide both sides by 2. And so we're going to get negative 1 is equal to cos of x minus 60. And we obviously need to find x. So we would use our inverse formula. So x minus 60 would equal the inverse cos of -1. -1. And of course, from our general solution, we've got that plus or minus in front, plus k 360, where k is an element of integers. We know that that would then give us x minus 60 is plus or minus 180 plus k 360. We move the 60 over, and of course we would assume that we're dealing with the negative solution because we're on the negative part of the x-axis. So it would be x is equal to negative, and then 180 plus 60, which would be 120 degrees. So x of negative 120 degrees. But the question says to us, find the y-coordinate of f, where x is equal to 120, and the y-coordinate of g, when it's equal to 120. So we can go and simply substitute that in for ourselves. So f of negative 120 minus g of negative 120 would give us negative 3 sine of negative 120 over 2 minus, and then g of negative 120 is simply negative 2, because we've already worked that out as our y-coordinate. And when we go and plug that into our calc, it gives us 4 plus 3 root 3 over 2. So quite a difficult question, but it involved all about finding that p-value, which was the x-coordinate over there. The last question here, it says determine the values of x. Once again, we know it's saying values of x. So we're talking about giving our answer in the form of a domain, giving it in the form of x as an element of, or using inequality notation. And it says for which g of x is less than 0. So again, in the given interval, we know that we've got the negative 180 there, and we end at positive 180 over there. We're only worried about between those 2 points. We don't care about anything else. What we do worry about, though, is where it is less than 0. And wherever you see something that's less than 0, you need to basically be thinking that it is below the x-axis. So where is g of x below the x-axis? And so if we highlight g of x over there, you'll see that it's below the x-axis from there all the way along. But the moment we hit this point over here, it starts moving above the x-axis. So that doesn't help us. And as we carry on moving along the function, eventually we hit the axis again, and it moves below the x-axis. So before we can actually answer this question, we need that point there and that point there. And do you see how both of those points are actually our x-intercepts? And where we have x-intercepts, we know that y is 0 over there. And so we take our formula for g of x, and we let y equal 0. So it would become 0 is 2 cos of x minus 60. And then when we solved it, it would become cos of x minus 60 equals 0, because we divide both sides by 2 to get rid of that 2 over there. But obviously dividing anything by 2 gives us 0, or dividing 0 by 2 still gives us 0. So therefore x minus 60 would be the inverse cos of 0. Don't forget your plus or minus and your K360 from your general solution. And so we would end up with the following. X minus 60 is plus or minus 90 plus k360. So therefore x is equal to either positive 90 plus 60, which would be 150, or x would be negative 90 plus 60, which is negative 30 degrees. And that's obviously just using that plus or minus there, and then moving the 60 over. And the 360 stays, but in our case, we're only dealing with negative 180 to 180. So we don't need to use that K360 over there. And so we know that this point over there is obviously negative 30, and this point over there is positive 150. And so our answer for the first bit will be from the negative 80, 180, all the way up to the negative 30. So that would be x is an element of, make sure you look over there, we are not including. So negative 180, we are below the x-axis. So we can put the square bracket because negative 180 is below the x-axis. So there's our negative 180. But the 30 is on the x-axis, which means it's actually equal to 0. And so the negative 30 would have a round bracket. Likewise as well, for the second bit, from there to there, we know that it would be x is an element of, that 150 is on the axis, so it would be a round bracket, positive 150 up to positive 180. The 180 is below, and so we would have a square bracket like so. And just in case anyone is wondering, using inequality notation, we would say x is between negative 180 and negative 30. And for there, it would be x is between 150 and 180. And those two together, there and there, or there and there, would be the solution to the question.